Afterwards, there will be a possibility to ask questions, and we will not record that. It is my great pleasure to welcome Lozana Rossenova of NFDI4Culture and also of the Open Science Lab of TIB, which is the German National Library of Science and Technology. Lozana is a postdoc researcher at TIB's Open Science Lab and works in two task areas of NFDI4Culture, which is data enrichment and knowledge graphs, with a focus on Wikibase, so the software behind Wikidata. And Lozana is also project manager for the semantic annotation, a minimum viable product. So what this is, she will explain in this talk. She is also the designated Wikibase community manager for NFDI4Culture. The topic of her presentation is Semantic Annotation for 3D Objects, a Minimum Viable Product, MVP, from NFDI4Culture. Lozana, we are looking forward to your talk. The floor is yours.
Thank you so much, Cord. Welcome, everyone. I will also just preface this talk by saying that one of my colleagues was supposed to join us here today, Lukas Gunther. Unfortunately, due to health issues, he's not able to. Therefore, I have two other colleagues from NFDI4Culture joining for the Q&A specifically, Paul Duchesne and Richard Vogt. Paul also works at the Open Science Lab as a Wikibase developer, and Richard works at the University of Bonn, and he's our expert on 3D objects. So I will now share my screen and start the talk. Hopefully you can see the presentation full screen. So as Cord already introduced, this is the topic for today, semantic annotation for 3D objects, our MVP tool. And I have to say that I am presenting this, but of course we have a large team and everyone is listed here on the slide. A little bit about NFDI4Culture for those of you joining us today from different NFDIs or other research contexts in Germany. The NFDI4Culture consortium is focused on infrastructure for research data around cultural heritage, and we work with both tangible and intangible cultural objects. In task area 1, which is the task area this current product is being developed in, we primarily deal with data capture and enrichment of digital cultural assets. So this minimum viable product that we are working on, the core concept is to enrich 3D objects. And how we're doing this is by connecting a Wikibase instance, which we're using for linked open data management, with the compact viewer for 3D image preview and annotation. And in addition, we are also using OpenRefine for our data upload pipeline. All of these three tools, is important to mention that they're all open source software. This is very important for us as we want to be working with open source software and of course pursuing the FAIR principles that are very important for NFDI4Culture and NFDI in general. What you're seeing here on the slide is a very early mock-up of our core ideas, and actually what you're seeing on the left is Wikidata, so it's not Wikibase, and what you're seeing on the right is a public version of Compact. And the idea in the beginning of this project was that Compact is a fantastic software for looking and exploring and annotating 3D objects, as well as other kinds of rich media, including audio, video files. But all the data there is flat. It's not really structured, and there is no kind of proper database that you can access and work with this data. At the same time, Wikidata is a very large public resource for linked open data, but it tends to work really well for text-based data and very simple media files, but nothing complex like 3D objects. And similarly also for Wikibase, which you can spin up obviously completely independently from Wikidata, but again, it doesn't really let you interact with more complex objects, which is actually very important for NFDI4Culture. And while we were conceptualizing this project from the start, we wanted to work with real data. We wanted to really focus on use cases that can be of immediate help to our community. So we reached out to various community members and we got in touch with the CBDD project. So this is Corpus der Barocken Deckenmalerei, which is led by a team of researchers in Munich, in the Cultural Art History Institute there in LMU. And they had this very interesting data set of data around different castles around Germany. And we focused to work on particularly one castle, which was very rich in terms of the data available. So the Weikersheim Castle had all sorts of art historical data, 3D models of the painted ceilings, entire reconstructions of sections of the building, video files, all sorts of plans, and parts of the data were also already structured as linked data. Now, what you see here on the slide and why I'm talking about it for so long is that on the right-hand side, you can see a screenshot from the table of contents from the current platform, which is also linked from the slides, and I'm happy to share the slides after the talk. So these contents show how data is currently presented in a web platform. In other words, it's really not structured. Everything is quite text-based, and it's very, very difficult to navigate when you have a very, very complex building with complex data sets attached to it. So we wanted to really focus on this problem and work on it. Why we are using linked open data and Wikibase for this, I won't go into detail because I assume most people in the audience here today are very familiar with linked open data and the benefits, but primarily we were focused on reducing the siloing of data and the redundancy. So instead of having to replicate the same data over multiple systems, separate systems, right? Systems that deal on the one hand with art historical data, on the other hand with 3D models, on the other hand with 2D models and 2D images, sorry, and potentially also completely separate other databases for flat plans. We wanted to combine everything into an integrated system. And most of all, we wanted to work with a system that would allow us to then extend and connect to other resources, such as the NFDI4Culture knowledge graph, Wikidata, etc. Next, why we wanted to work with Compact. As I mentioned in the beginning, we were focused on working with media that had a variety of file types, right? So images, but also videos and 3D objects. And for this purpose, Wikibase alone, or even besides Wikibase, any kind of linked open data system alone cannot really do this. You need an additional component. And Compact was very suitable because it was an open source project. It was being developed by partners of NFDI4Culture anyway from the University of Cologne. So we had direct access to the development team there, and it follows standards, right? So it's using the W3C standard for annotations. So I thought this was a great opportunity to connect with Wikibase. Maybe a little bit more information about Compact and why specifically we chose it. This is for everyone in the room interested in 3D models and renderers. Of course, there's loads of different options for 3D objects, but one of the benefits of Compact that none of the other tools that we looked at and that were studied in case studies like this one, for example, that I'm referencing here, basically none of these other tools allowed for the kind of annotation that we wanted. So collaborative standards compliant annotation, which is why we focused on Compact in the end. And this is a view of our architecture of the MVP. So we have a very modular system, and like I said, very much focused on use cases from the very beginning. So at the top here, you can see the user interaction workflows. Of course, the beginning is data cleaning and upload, next metadata storage and indexing, and finally media presentation and annotation. And all of our components here are modular, so we could potentially, depending on specific use cases in the future, take out certain components, replace them, whether it's on the storage layer, and we are indeed looking to different storage options for the future in terms of triple store at the very least, but potentially also in terms of search indexing, etc. And then also in terms of front end, how exactly these different front ends are used and embedded into other systems. This is also very flexible. So this is just an example of a Wikibase instance. Again, it's linked from the slide, so you will all be able to click these links after the talk and explore further. After setting up the Wikibase instance, the next component of our workflow was setting up this data upload pipeline, and it consists of 4 elements: data collection, data modeling, data transformation and reconciliation, and finally upload. So in the first phase, the collecting stage, of course, we worked very closely with our data partners to gather all the different types of data that we wanted to use in our MVP development process. Next, we developed a data model that was based on established vocabularies. So it's important to mention that you will have a chance to look at this data model, again, clicking from here. But what I want to emphasize is that this is not something set in stone. We just wanted to find a working data model that built on the vocabularies already used within the Corpus der Barocken Deckenmalerei project. And we made most of our data compliant with Wikidata. But this is, of course, not the only mapping we're looking to work with. This is just a very first step that makes it easy to federate at the very minimum with Wikidata. But in the future, we want to work with further mappings. As a next step, we wanted to, again, focus on a workflow that will be completely accessible throughout every stage of the process. So we wanted to work with the tool that our users can work with directly. So we focused on OpenRefine, which is a popular tool in the GLAM communities. And we established a reconciliation service for our Wikibase. And we also created this service box for OpenRefine so that anyone in the NFDI community, if interested, can use our service box to very easily configure and deploy an OpenRefine instance for their own purposes to connect with the Wikibase, for example. And we used it to transform and clean the data and to model it according to our established Wikibase data model. Next, we uploaded the data to our sample Wikibase, and I have to say we used OpenRefine for almost all of the upload with a minimum amount of bot scripting for just a few automation procedures. The workflow that we're developing at the moment can be visualized in this very high-level diagram, but I have to emphasize it's high-level, right? So we don't really go into the details. So we start with establishing a Wikibase instance. We upload different kinds of data into that instance, and then we start thinking about media. So do we want to upload in bulk? Yes or no? And right now, what we'll be showing in the demo today is this more manual approach. So you have to upload the media manually in Compact, and then you can do manual annotations. But all of this is then semantified, so to say, and pushed back into the Wikibase. So it's searchable via the Sparkle endpoint of Wikibase. And it's also made at the same time made public on the Compact instance that we have, which has this much nicer interface than the standard Wikibase database. As a next phase, we will be working on bulk and automated operations, and we're kicking off this in May this year. So for those interested, this was the kind of first phase we conceptualized through some wireframes, but I will actually be showing the demo version today, how it's already working. So this is just an example of what it was sort of the before, right? Compact before our integration work. You just had a 3D model on the left-hand side that was, of course, interactive. And then on the right-hand side, you had a minimum level of metadata that was not structured and not stored in any database, just flat. And then in the new version of Compact that we've developed, again, you have the 3D models on the left, but on the right, all the metadata is structured and is saved directly in Wikibase, and it's being pulled from Wikibase to display, including things like this potential way to display structure right within something like a building. You had different sections and then different rooms, etc. And before I delve into the actual demo and show how all this works, I just wanted to mention a few more things that wrap up the slides. All of our development is open. We have an open GitLab instance that is accessible through this link here, and everyone is welcome to have a look at it if you want and are willing to contribute even as reviewers or in any other capacity. Do get in touch with us. We're very happy to have more collaborators. We also have an open requirements gathering space in GitLab that anyone can submit requirements to. And finally, just a few words on next steps and kind of outlook with this development. First, we want to better align our custom version of Compact with the mainline Compact development. So in order to basically stay up to date easily and minimize future maintenance. We do want to also include a point cloud renderer into our MVP release. This is something that Compact out of the box doesn't do, but Richard, who is joining us here today, has developed a point cloud renderer, and this will be integrated into the next phase of our MVP. We are also working towards better integration of semantic capabilities via automation and entity recognition. So right now, working with natural language text is quite manual, but we hope to be able to introduce automation in there pretty soon. We're also working towards, as I mentioned already earlier, bulk operations and further standardization and alignment with additional standards. And last but not least, I already mentioned we have a service box for OpenRefine. Wikibase itself is Dockerized, but our ultimate goal when this MVP is out of MVP phase and it's a finished product rather than a minimum viable product, we want to containerize via Docker and automate the deployment of all of our tools, right? So this tool chain of OpenRefine, Wikibase, and Compact ideally will be containerized and easily deployable as a suite. So this is it for the slides. I'm now going to end the slide share and play the video. Hopefully full screen and working. Welcome to this demo of our Compact and Wikibase integration. We will start with uploading a folder into Compact for one of our example 3D objects. So I have just selected a folder from my computer. All right. Once the upload is complete, we can progress to the next step. Once we have our object loaded, we can tweak some settings, but in this demo I will just proceed without further changes. Okay, and now we can move forward. And this is the point where our Compact interface interacts with Wikibase. We'll start entering information that will be saved into Wikibase. Starting with the title for this object, so we could call it Dining Room Reconstruction 3D model or something like this. The description is the short disambiguation text that will also be saved on Wikibase alongside the item's title. And here we'll just say that this is a demo upload. And we also have choices of language. I will stick with English for now, but we could of course add more languages. So here we need to pick an agent that is related to this object, and in this case it's one of our collaborators, Jan, and he's the rights owner and the creator. These are the two required roles, but you could add more people with different roles for every object. And finally we have to pick a license, and we have a choice of licenses. And now we could progress to the next step, or we could also add some additional but non-mandatory metadata, for example the technique. And again we have some pre-available vocabularies here that we're pulling from Wikibase. And we also have some software examples. We can also add a date, for example the day's date. We add all these pieces. We could add, for example, a bibliographic reference. We have just one example item, but this will be up to you to enter the items that you need. Finally, something that is also important is to link what this particular 3D model represents in the physical world. So we have these related physical objects, and in this case this is a dining room from our dataset of the Vickersheim Castle, so add that as well. Now we are ready to progress and finish our object upload. And now the object upload is finished. We get to preview how it looks in the Compact interface, and We can either go straight ahead and publish it, so it will be discoverable in the Explore menu, or we could do some annotations before that. All the metadata that we see here is the data we entered during the upload process, and it's data that is stored in Wikibase. Interestingly, we can also look at the object structure. Now here we see where this particular physical room is situated in the overall structure of the castle, and all of these links here will take us directly to the object records for these items in the Wikibase instance. Now we can of course interact with the 3D model here in different ways, and we can use all of the normal functions of Compact, but just for the purposes of the demo, I'll go straight ahead into the annotation mode so we can demo how annotations work also with our Wikibase instance. While the model is loading for annotation, we could check here in our Wikibase in recent changes if our object has been uploaded. Yes, indeed. And we can see the metadata here as well as a quick preview thumbnail. Let's go back to Compact. So we are now ready for annotations, and I would like to annotate some of the paintings that we have. Just need to rotate in the right position. I'll start here from the hallway. So you just need to double click and the annotation editing menu will open. I prefer to go straight into the full screen mode for this annotation process. And here we can start with the title of the ceiling painting that we want to annotate, which is Venus Morning Adonis, or this is a shorter version I'm just using for the demo. In terms of text, we do have some art historical texts that we can use, so I won't take the whole text, but I'll just take a part of it and add in my description here. What is new in our modified version of Compact is that besides adding text and images like you can in the standard version of Compact, you can also add related media from our wiki. You have the option to add URL to media item from anywhere else. So in this case, we could add something from the CBDD corpus, or you could add semantic concepts. So in this case, let's go ahead and add the Venus Morning Adonis. This is our item corresponding to the icon class notation, so we can add that. So in terms of our images, I can go directly to the Corpus der Barocken Deckenmalerei website and get one of the images links from here to include in my annotation. And now I have an image, we have a concept coming from the wiki, we have some text. We can save our annotation. That's it. And if I now go ahead and want to publish, I can find my object in the menu here. And I think at this point I will stop the video because I can go back to the live. I wasn't sure basically how the whole process will go, so that's why we did a video. I hope it was clear enough, but this is actually the live version right now in Compact on the web, and what you just saw in terms of like adding annotations, this is how the final annotations look. This is another one for another painting. Everyone can have a look at this if you go in our version of Compact and look at this example object. So with this, I think I will finish the formal part of the presentation. Actually, I won't stop sharing it yet because I might want to show a few more things, but perhaps we can finish with the recording if that's okay with our NFDI hosts, and we can take some questions